When being asked for the zeros of a function, it only wants to know what values that when you plug it into the function will result in an answer of 0. To find this out, just set the function equal to 0 and solve. The results are called the zeros of the function. So when they say find the zeros, just set the function equal to 0 and solve. So for the first one, f of x equals x squared plus 9x plus 14. We just want to set it equal to 0 like so. So x squared plus 9x plus 14 equals 0. And we're just going to solve. So we're going to factor this out. So what times what will give us 14, but add together to give us 9. In this case, it's positive 7 and positive 2. So x plus 7, x plus 2. And then once we get it to the factored form like this, we're just going to set each parentheses on their own equal to 0. And then we're going to solve. So subtract 7 over, and we're going to get x equals negative 7. Subtract the 2 over, and we're going to get x equals negative 2. You can write your answers like this. That's acceptable. You can even go down and write your answers like this if you want to. The order is not really relevant, just whatever you think is easiest. But whether you have it separate or all together, those are the zeros of this function. Next we have h of t equals 6t squared minus 25t minus 9, and we're going to find the zeros of this function. So we just take our function like so and set it equal to 0. So 6 times negative 9 is going to give us negative 54. So what times what will give us negative 54, but we'll add to give us negative 25. And in this case, it's going to be negative 27 and positive 2. So setting up our parentheses, t minus 27, t plus 2. And since our leading coefficient is a 6, divide both of our factors by 6. So 27 over 6 is going to reduce down to 9 over 2. 2 over 6 will also reduce down. It will be 1 over 3. And again, just like before, we take each parentheses and set them equal to 0. So t minus 9 halves equals 0, and t plus 1/3 equals 0. Add the 9 halves over, t equals 9 halves, and then subtract the 1/3 over, t equals negative 1/3. And here are our two solutions for this function. These are the zeros. Last, s of t equals 2t cubed plus 2t squared minus 40t. So we want to set this equal to 0. So 2t cubed plus 2t squared minus 40t equals 0. And I look at this and I can see immediately there's a GCF. And if I can make my life easier, I'm going to do that. I want these numbers to be smaller. So I can factor a 2t out of the whole thing. And when I do that, I'm going to be left with t squared plus t minus 20 equals 0. And now I got the 2t off on its own, which is fine, but I still need to factor my quadratic in the middle. So what times what's going to give me 20? But if I add it together, I'm going to get 1. And the reason why it's 20 is because of this here being a coefficient of 1. I don't worry about the 2, just this number here. So what are my factors? Positive 5 and negative 4. So 2t, and then the factor form here is going to be t plus 5 and t minus 4. And now I'm going to set all three equal to 0. So 2t equals 0, t plus 5 equals 0, t minus 4 equals 0. And now I solve. Divide 2 over on both sides. T is going to equal 0. There's 1. Subtract 5 over. T equals negative 5. There's 2. And then add 4 over. T equals positive 4. That's 3. So here are my 3 zeros for this function.